Hello, welcome. We are still here talking about current. So current passes through a solution of your sodium chloride in 1 second, 2.68 times 10 raised to 16. This is supposed to be Na plus, so let me just correct it. Na plus ions arrive at the negative electrode, and 3.92 times 10 raised to 16 Cl minus, this is minus ions, arrive at the positive electrode. Firstly, what is the current passing between the electrodes? Current passing between the electrodes. We're looking for the current passing between the electrodes. What we do have is 2.68 times 10 raised to 16 positive sodium ions and 3.92 times 10 raised to 16 negative Cl ions. So how do we proceed here? We're just looking for our I. So here, okay. I is equal to, if you do remember, your I is equal to Q over T. That's the rate. Remember that I is a flow. And if you're a little bit confused, you can check out the last video published. And we also use this formula to refer to the rate of charge flowing. So let's proceed here. What we know is time. We've got time here equals 1.00 seconds. And we have the ions, the 2.68, 3.92. Now, how do we get the Q? First things first, to get the Q, we've got to have the N times your, times your small q. So that is, okay, the charge. We're looking for the magnitude here, small q. Okay, so your N basically is a number of positive and negative ions. We've got here two kinds, positive and negative. So we are going to just copy the N for Na plus N for Cl times your Q. So for your N, that is 2.68 times 10 raised to 16 added to your Cl, 3.92 times 10 raised to 16 as well. Multiply to Q. Your Q, this is the absolute value. It's actually negative 1.6, but this is absolute, so that's just 1.6 times 10 raised to 19. Whoops. Okay. 1.6 times 10 raised to negative 19. That's what I wanted to say. So here, there you go. Calculate, you'll be able to get 0.01. This is 0. Whoopsie. Trying to make it better and it's just worsening. 0.01056 Coulomb. Plugging in the values. Plugging in, we've got here our I. We have here 0.01056 C divided by your 1 second. That'll just give us the same thing, 0.01056, but this time it's amperes, or 10.56 milliamperes. That's it. Now for letter B, what's the direction of your current? So we are now referring to the direction. Conventionally, the current will flow toward the negative electrode, because if you remember in the laboratory, your current would be coming from your positive. So positive to negative. So what's the direction of the current? Toward the negative electrode.